Okay, this is part 2 of the binomial theorem video, so we're going to continue. So we did an example of expanding x plus 2 to the 5th using the binomial coefficient. So let's try another example. What about expanding something that looks a little bit different? Let's say x squared minus 1 over x to the 3rd. So I'm going to keep the exponents small just so that we can practice when our a and our b look a little different. So in this case, a is x squared and b is negative 1 over x. So if you have a negative there, make sure that you would put the negative with it, because our formula, or the binomial coefficient, is for when you have a plus b to the n. So if there's a plus in there, that's when it works. So if there's a negative, you have to then put it as part of the b. So using the binomial expansion on this, we're going to get x squared minus 1 over x cubed is going to be, so my n is 3. So it's going to be 3, choose 0. We always start at 0. And then a, so x squared to the 3rd. And b to the 0. So we don't write that one because anything to the 0 power is 1. Plus 3, choose 1 of a squared, right? We're going to decrease the power of 3 to 2. So by my a is x squared. So I'm going to have x squared times b to the 1st times negative 1 over x to the 1st. So plus, then 3, choose 2 of x squared to the 1st power, right? The a, so it starts with a cubed, a squared, a to the 1st. But our a looks different, is x squared. And now we started with b to the 0, b to the 1, and now b squared. So minus 1 over x squared. And lastly, 3, choose 3. And now we're going to have our a to the 0, so we don't write that one. And b, so negative 1 over x to the 3rd. And so we just figure out what these are. 3 to the 0 and choose 0 is 1. So I'm going to have 1 times x to the 6 plus 3 choose 1 is 3, but you can do it out, right? That would be 3 factorial over 1 factorial times 3 minus 1 factorial, which is 2 factorial. And so remember, using that trick, 3 factorial is 3 times 2 factorial, so the 2 factorials cancel. So that's how we just get the 3. And x squared squared, so it'll be x to the 4th times negative 1 over x. So we'll come back through and simplify all of this. 3, choose 2, so that's 3 factorial over 2 factorial times 3 minus 1 factorial, which is 1. 3 minus 2 factorial, sorry, which is 1 factorial. And then x squared to the 1st, so that's just x squared times negative 1 over x squared. A negative square becomes positive, so this will just be 1 over x squared. Plus 3, choose 3, we know that that's 1. And I'm going to have negative 1 over x cubed. That's it times. And so now let's come back and simplify everything. So I have my coefficient here. This looks a little messy, sorry. That's 3 after we reduce everything. So I'm going to have x to the 6 plus 3. And I have x to the 4th times a negative 1 over x. So x to the 4th divided by x is actually x cubed. And because I have that negative, this plus is really a minus 3 x cubed. And then here, what's our coefficient going to be? Right, that's the same as that one. 3 factorial is 3 times 2 times 1. With that 2 factorial, it's going to cancel out, and it's going to stay plus. So plus 3 x squared times 1 over x squared is just x to the 0, so they cancel out. And then minus 1 over x cubed. So this will be the expansion for this particular problem. So x squared minus 1 over x cubed is equal to this. Now, if you had this something to like the 10th, we would continue that. But hopefully, we don't have to do that many. So one of the other things that you will be asked to do is find a specific term. So let's go back to the expansion. And so I did this in the previous video, I just kept the same notes. But a plus b to the n using the binomial expansion instead. So what I want to focus on right now is the R term. So this one. So to find any particular term, if it's a to the r, then we can find it by using this general form. So we're gonna go back and say a particular term. So we're gonna say the term that contains a to the r is in the expansion is that term that we just saw. So it's n choose r times a to the r b to the n minus r. So say we want to find the term that contains x to the fifth in an expansion. So find the coefficient of x to the fifth in the expansion of, say, x plus 3 to the 8th. So how would I do that? Well, because this is just x, there's just the one x and there are no x's over here, it's just going to go x to the 8th, x to the 7th, x to the 6th, x to the 5th, and it's just going to decrease like that. So then what that means is that my r is 5. So I'm going to do and choose r, right, that term. So what is my n? N is 5. So we're going to say 5, oops, sorry, no, n is not 5, r is 5, n is 8. So we're going to say 8 choose 5, a to the r, so we're going to have a to the fifth times b to the 8 minus 5, which is 3. So that's going to be 8 choose 5, what's a? A is x, so be x to the fifth, and what's b? B is 3, so be 3 to the 8 minus 5, which is 3. And so we do that, the definition of 8 choose 5. So that will be 8 factorial divided by 5 factorial times 8 minus 5. So 3 factorial times x to the fifth, and 3 cubed is 27. And so let's simplify the 8 factorial. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But I'm going to say times 5 factorial so that I can reduce it with the 5 factorial on the bottom. And so we can cancel off, divide out the 5 factorials. And 3 factorial is 3 times 2 times 1. So let's see, what else can we get rid of? Oh, that's 6. So that 6 can cancel out as well. So it's just 8 times 7, which is 42, times 27, x to the fifth. So we were asked for the coefficient. So the coefficient is that 42 times 27, which is 1,134. X to the fifth. So the term that we're looking for, or the answer, would be 1134. And the reason that it's not just the 8 choose 5 factorial is because our b was 3. So we end up getting that coefficient with the powers of 3 mixed in there. Okay, so let's try another example. Okay, so in this second example, we want to find the term containing x squared in the expansion of 8x plus 1 over 2x to the 6. So notice that here, my a, our a is 8x, and b is 1 over 2x. So when I do linear expansion, when we start doing the powers of a times b, notice that, or if I just do right away a times b, my x's are going to cancel. So the term that contains x squared is not necessarily that r equals 2, because as I multiply my a and my b, 8x times 1 over 2x, different powers of these are going to act differently. So we actually don't know what r is. So I'm going to write that down. We don't know r. So what we're going to do in this case is we're going to say, well, I know n is 6. And I know we want the term to have x squared. So we're going to try to get that n minus r to be 2. So we'll see what we get here. So we're going to start with the term 6 choose r. So that's our coefficient. We don't know r, so that means it's going to be 8x by a to the r times b. B is 1 over 2x to the n minus r. And so we're trying to figure out how we're going to get x squared out of here. So we can continue this way in simplifying the x term. So I'm going to have 6 choose r times multiply these out, right? So we're going to have 8 to the r, x to the r times and 1 over, so this is just going to be 1 over 2 to the n minus r times x to the n minus r. Now remember, we're trying to figure out when are we going to get x squared. So let's combine the x's. I'm going to move over here. So 6 choose r times, combine the 8. So I'm going to have 8 to the r over 2 to the n minus r. Well, we do know that n is 6. So let me insert our 6 for the n to make it better. So 6 minus r, 6 minus r, 6 minus r, because we know already that n is 6. I need to also get rid of it there. So I have 8 to the r over 2 to the 6 minus r. So that's our coefficient that will go with the 6 choose r times, and now the x's. I have x to the r, and from here, x to the r over x to the 6 minus r. Now remember, we're trying to find the coefficient of x squared. So I've gotten my x's separated here. So I want this to be equal to x squared. So that's what we're going to work with. So I'm going to have 6 choose r times 8 to the r. And you can simplify this. We know that 8 is equal to 2 cubed. So 8 to the r will be 2 to the 3r. But for right now, I'm going to keep it this way. So 2 to the 6 minus r times, when you divide the same basis, what do you do with the exponents? We subtract, right? So then this will be x to the r minus 6 minus r. And let's keep going. So 6 choose r, 8 to the r, 2 to the 6 minus r, times x to the, so what do I get here? So distribute that negative, so minus 6 minus a minus becomes plus. So this is really r minus 6 plus r, so it's 2r minus 6. And now we are in good shape because I've isolated my x term. And remember, we're looking for x squared. So we want to have x squared. So that means that what I want is for 2r minus 6 to be equal to 2. Okay, so I want those exponents to be the same. And solve for r. So add 2 to both sides. So 2r equals 8, which means that r is 4. And so now we can go back, and everywhere we see an r, we can plug in the 4 and make sure that it works. So with r equals 4, we're going to get 6 choose 4 times 8 to the 4 over 2 to the 6 minus 4. It's because r is 4 times x to the 2 times 4 minus 6. And notice that that exponent 2 times 4 is 8 minus 6 is 2, which is what we want. So 6 choose 4, that's 6 factorial divided by 4 factorial times 6 minus 2, 6 minus 4, which is 2, times 8 to the 4th divided by 2 squared times x squared. And so we were asked to find the term. So 6 factorial, you can write it as 6 times 5 times 4 times 3 times 2 times 1, or I can just say 4 factorial divided by 4 factorial, 2 factorial, and then what is this? 8 to the 4th times, or divided by 2 squared. So this becomes, right, if you think about what we said, that 8 is 2 cubed, so this is 2 cubed to the 4th, power to the power, so this is 2 to the 12th. So 2 to the 12th divided by 2 squared, subtract the exponents, you get 2 to the 10th. And simplify. So 4 factorials cancel out. 2 factorial is just 2. So we have 6 times 5, which is 30, divided by 2. So 30 divided by 2 times 2 to the 10th, x squared. And when you do this, you get, I got 15,360 x squared when I put in my calculator. So this will be the term that we're after. We were asked to find the term that contains x squared. And so we had to do it this way because or A and or B both included an x. So I can't just say, oh, the one that gives me x squared. I can't just say that r is equal to 2 because my terms, my A and my B both have an x and they're canceling off. And so, and by doing this way, we actually found that r is equal to 4. And that gives us the term that we were after. So one of the things for the particular term is to remember that formula that we wrote over here. The term that contains a to the r is n choose r, a to the r, b to the n minus r. So when we don't know r, that's where things get a little bit complicated. But there'll be some problems like this in your homework. Email me if you have any questions.